Good day, students. So welcome to part 3 of the Geometry Regents exam for January 2013. In this installment, we're going to be going over questions 11 through 15. All right, so let's go ahead and take a look at question number 11. It says triangle ABC is shown in the diagram below. If DE joins midpoints of ADC and A inside AEB, which statement is not true? Okay, so let's take a look at what we have here. If this is the midpoint of AC, that means this side, segment DC is congruent to segment AD, and if this is the midpoint of AB, then AE is also congruent to EB. All right, and then we know that angle A is congruent to itself. Now, what we're going to review real quick is the similarity postulates. Remember the similarity postulates? We have AA. If two angles of a triangle are congruent, then the two triangles are similar. Two corresponding angles are congruent and they're similar. Then you also have SSS. If three sides are in proportion, then the two triangles are similar. And then you also have SAS. If two corresponding sides are proportional and you have one and the corresponding angles are congruent, then you also have similarity. Okay, so these are the three cases for similarity here, and we're going to apply it here to this situation. But before we do that, let's see what we have. Since D is a midpoint, that means that AD is going to be half of the entire length. So let's write down some equations. AD is going to be equal to 1/2 of AC. Okay, all right, and we also know that AE is going to be 1/2 of the entire length, so AE is going to be 1/2 of the entire length, which is AB. All right, so since they will have the same ratio right here, we see that the same constant of proportionality applies to both sides. Okay, so we have two sides that are proportional. What do we know about the angle? Well, we know that angle A is congruent to itself, so we have similarity. We have two similar triangles. Okay, so just to show you how it works, I'm concluding that we have SAS situation here. So how do we know that? For S, we know that side AD in a small triangle is similar to side DC. It's compressed by a factor of 1/2. Okay, that's the constant of proportionality. And then for the A, I know that angle A is congruent to itself using the reflexive property. Angle A is congruent to angle A. And then for the next S, I know that AE in the small triangle is similar to segment to side AB in the big triangle using the same concept of proportionality, which is 1/2 as we have up here. So it's the same factor. We determined that here. Okay, so since we have two corresponding sides being proportional, namely they have the same constant of proportionality, and we have an angle congruent to itself, two corresponding angles congruent to themselves, we can conclude that these two triangles are in fact similar. So the big triangle, triangle ABC, is in fact similar to the small triangle ADE using the SAS similarity postulate. Okay, actually let me follow the order since we're labeling it like that. So it's going to be angle A is similar to A, and then B is similar to E, so we have to be careful here. So angle AED. Alright, so there goes our conclusion. Okay, now so which of this is the following is not true based on the fact that these two triangles are similar? Option 1, DE, which is this side, is equal to 1/2 CB. That is absolutely true because what is the constant of proportionality here is 1/2, right? Whenever you take half of any side in the large triangle, you get the corresponding side of the small triangle. So it's easy for us to see that if we're looking for DE, you follow the same pattern right here. You always take 1/2 of the corresponding side of the big triangle. So The corresponding side to DE on the big triangle is CB, so we just take 1/2 of CB to get the measure of DE, and that's consistent with option number 1. So this is good. All right, DE is parallel to CB. In order for DE to parallel to CB, we just have, if we can show that two corresponding angles are congruent for these two lines, then we will conclude that, we can conclude that they're parallel. If we have, so what we're looking at here, right here is, we have a transversal. Let's look at this as a transversal, and we have these two angles. If I can show that these two angles are congruent, then I can know that these two lines are parallel. Okay, because if you have two lines caused by transversal and corresponding angles are congruent, then the two lines must be parallel. Okay, so what do we know about these two triangles? Well, since triangle ABC is similar to triangle AED, then every pair of corresponding angles are congruent. So angle D is congruent to angle C, because these two triangles are similar and these two angles are corresponding. Okay, they're corresponding angles. So these angles are the same. So since these two angles are the same, guess what? We have a common transversal and corresponding angles are congruent. It follows that these two lines must be parallel. Okay, because these two angles are the same. You can also make the same argument using these two angles. These are corresponding angles to this transversal, and since these two triangles are similar, these two angles must be congruent to their corresponding angles. All right, and that follows that these two lines are proportional also. So we can easily conclude that DE is in fact parallel to CB, because the corresponding angles due to similarity are congruent. Okay. All right, let's move to option 3. It says AD. Well, if we can jump to 4, ABC is similar to AED. We already concluded that here, so we know that that's correct. So using the method of elimination, we can easily conclude that this is the answer. Well, let's show that though. So it says AD, which is this side of the small triangle, over DC, which is that side of the big triangle, is equal to DE over CB. Okay, so DE is the base of a small triangle over the base of the big triangle, CB. That makes sense. That's good. But if you look at this ratio right here, AC is the left side of the small triangle. Over is supposed to be, it cannot be DC, it has to be over AC. Okay, because AD corresponds with AC. AD does not correspond with DC. Okay, so this is a wrong side right here. So that makes option 3 incorrect. So since that is a statement that is not true, the question is asking for which statement is not true. That is the only one that's not true. Hence our answer is option number 3. Okay? So there you have it. All right, let's move on to question number 12. Question 12 says the equation x squared plus y squared equals 25 and y equals 5 are graphed on a set of axes. What is the solution of the system? All right, so it says the equation x squared plus y squared equals 25 and y equals 5 are graphed on a set of axes. What is the solution to this system? So you have to just remember that the solution to a set of systems is a point of intersection, okay? So the question is, where do these two lines intersect? So the first one we can clearly see is a circle with radius 5. So x squared plus y squared equals 25 is a circle centered around the origin with a radius of 5. So the center is 0, 0, and the radius r is the square root of the number you have on the right side, which is 25, and that's 5, okay? All right, so let's go ahead and graph that on this coordinate system I have here. We're going to graph a circle with radius 5 centered around the origin, okay? All right, sketch that real quick. All right, so there you have the circle. So it's going 5 units in all directions. So this is 5 right here. That's 5, 5, 5, negative 5, negative 5. All right. Okay. Let me indicate what it is. This right here is this graph of the equation x squared plus y squared equals 25. Now, how about the line y equals 5? Y equals 5 is basically a line that is always 5 regardless of what x is. So let's graph 2 points. So when x is 5, y is what? It's going to be 5. When x is -7 right here, y is going to be what? 5. So y equals 5 is a line that's always 5, that always has a value of 5 on the y regardless of what x is, okay? So what kind of line is that? Well, it's a horizontal line going through y equals 5 on the x-axis, on the y-axis, okay? So the line y equals 5 is this line right here. So regardless of what x is, y is always going to be 5. So that's why we have a horizontal line, okay? Yeah, you went over that in algebra, so it's not too new. Anyway, so this line right here is a line with equation y equals 5. Now, the question is, where do they intersect? Wherever they intersect, that's going to be a solution, okay? So this is a cool graph right here because this line intersects a circle at exactly one point, the point of tangency, which is this point right here. And guess what? That point represents the solution to this system, okay? So what are the coordinates of this point? X is 0 and y is 5. So 0, 5 is the solution to your system of equations. So the answer is option number 3. All right, let's move on to question 13. It says square ABCD has vertices. These vertices right here. What is the length of a side of the square? Okay, so the vertices are in order. So all we need to do is just find the length of one side, right? So we can look for length of side AB, and that should tell us what the answer is, okay? So in order to do that, we need to use a formula, a distance formula. Use the distance formula. Hopefully you remember what the distance formula is, because let me make a sketch for you. Let's say we have a square like this, okay? And I want to compute the distance from, this is A, B, C, D. I want to compute this distance from here to here. Okay, if I'm given the coordinates x1, y1, x2, y2, then I can use the distance formula to compute how far the distance is. So the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. This is due to the Pythagorean theorem. Very good. This is a really powerful formula, so you want to memorize this formula because it's going to help you a lot in higher level mathematics, okay? All right, so this is the formula we're going to use. So since we just selected AB as our points to determine the side lengths, that's what we're going to input into our distance formula, okay? So A is -2, -3. B is 4, -1. So we must label our axes so we don't get confused, okay? The first point are the variables coordinates with 1 as the indices. So we have x1, y1. And then the second one has the 2 as the indices, okay? x2, y2. All right, now we're going to plug these values into the distance formula, simplify it as much as we can, and we should arrive at our correct result, all right? So the distance from A to B, which is corresponding to the side, length of a side of a square, is the square root of x2, which is 4, minus x1, which is -2, okay, square. Now you have to be really careful here whenever you're subtracting a negative. Some people might forget to include this minus. They might just put one minus there. So that'll be wrong because what we're going to be doing is actually adding, okay? So plus y2, -1, minus -3, okay? Square. So please be careful with the sign so you don't ruin the problem. Okay, so let's simplify that further. We're going to have the square root of, this is plus, minus times minus is a plus, 4 plus 2 is 6 square plus, -1, minus times a minus is plus, -1 plus 3 is +2 plus 2 square. That's going to be 36 plus 4, which equals square root of 40, okay? All right, we don't have that as an option here. We have to reduce this a little bit more. So let's break this down. 2 goes into 40, 20 times. 2 goes into 20, 10 times. 2 goes into 10, 5 times. Okay, so since we're taking the square root, any factor that repeats can be grouped together and they come out as 1, okay? So if you have 2 times 2, what is the square root of 2 times 2? The square root of 2 times 2 is just 2. So these two 2's come out as 1, as a 2. These other ones do not repeat, so they remain under the radical because they don't have a partner to break out with. So square root of 40 is going to be 2 times the square root of the product of the numbers that are left that could not come out, which is 2 and 5. If you multiply them together, you get 10. Okay, so 2 times 5 is 10. So your final answer is option number 2. All right, so there you have it. Okay, let's move on to number 4. All right, let's take a look at number 14. So we're told that in the diagram below, we have a triangle ABD. BE is perpendicular to AD, okay? And angle EBD is congruent to angle CBD. So let's indicate that EBD, that's angle right here, is congruent to triangle CBD, this angle right here. So these two angles are congruent. All right, if the measure of angle ABE is 52, ABE, this angle is 52, what is the measure of angle D? So we have to find that angle right there. Okay, so let's do it. So now, first thing we can do is we can find out the measure of angle EBC because it's a linear pair with angle EBA. So if they form a linear pair, we know that the sum of angles on a straight line is 180 degrees. Okay, so the sum of these two angles is are going to be this is going to be a supplement to this. Basically, they add up to 180. Okay, so let's go ahead and look for that. So using the linear pair postulate, we have a linear pair right here. These three angles form a linear pair, so we can say that. Let's see. Let me just write down those symbols first. Okay, measure of angle ABE plus measure of angle EBD plus measure of angle DBC equals 180. Okay, linear pair postulate says that the sum of angles on a straight line is 180 degrees. Okay, all right. So using that, what we can do now is make a substitution. So we have measure of angle AB is 52. So 52 degrees plus measure of angle EBD plus measure of angle DBC is equal to 180. So what I can do is subtract 52 degrees from both sides to get what the sum of these two angles are. Subtract 52. So what I'll have here is the measure of angle EBD plus the measure of angle DBC equals the difference. 180 minus 152, which is 100, and this is 10. Well, you get 128. Okay? All right, now what can we do next? We know that these two angles add up to 128 degrees because they are a linear pair with this angle, which is 52 degrees, okay? But wait a minute. They are congruent, right? They're the same angle, so if I divide 128 by 2, I can get one of them, right? So you can do that. You can easily figure out that one of them is going to be 64 degrees, but let me show you the steps. So for that one, I know that these two are congruent, right? So therefore I can say the measure of angle EBD plus the measure of angle EBD itself. What I did is I made a substitution with DBC with EBD because they're congruent equals 128. Okay? Since they're both the same, if you double angle EBD, if you double the measure, left out the M, if you double the measure of angle EBD, you get 128. So what does that tell me? If I divide both sides by 2, that will give me the measure of angle EBD. So divide by 2, divide by 2. So you have the measure of angle EBD, let's put it over here. Measure of angle EBD is equal to 64 degrees. Okay? All right, so this right here is 64. Let's put that in. This angle right here is 64 degrees. I'm just showing you all the symbols. You don't have to do this. You can use shortcuts. Anyway, there's 64 degrees. We all know that DE is congruent, is perpendicular to AD. So this right here is 90 degrees. So how on earth are we going to look for measure of angle D? Well, we know the triangle angle sum theorem tells us that the sum of angles in a triangle is 180. So if I add this 2 and subtract from 180, that will give me the measure of angle D. Okay? So using the triangle angle sum theorem, we can conclude that measure of angle D is equal to 180 minus the sum of the other two, since the entire sum of all three angles is 180. Okay? So 180 minus 90 plus 64. Okay? And then we can compute this manually. 180 minus 90 plus 64 is 154. And then when you subtract 180 from 154, you get 26 degrees. So that is the measure of angle D. So our answer is option number 1. Okay? So there you have it. Alright, so let's move on to question 15. It says, as shown in the diagram below, FD and CB intersect at a point A, and ET is perpendicular to both FD and CB at A, which statement is not true? So if you have two dissimilar lines, distinct lines intersecting at a point perpendicular to another line, then any 3 points on any of the lines that define the plane must be perpendicular to this line. Okay? So what are we saying? What am I saying? Let me show you something real quick. Alright, so what I just did is I basically constructed a plane. You see, since this line is perpendicular to that line, it falls on a plane that's perpendicular to this line right here, perpendicular to ET. And this line, since it's perpendicular to ET, the plane that this line is in, or the plane that contains the line, is also going to be perpendicular to ET also. Okay? So imagine that you have a pole standing on the ground, and the pole hits the ground at 90 degrees. Guess what? Any line on the ground is going to be perpendicular to that pole. Okay? So this big plane I have right here, this plane, defined by multiple points, is perpendicular to this line, because these two lines on the plane are perpendicular to this line. So pick any line at all is also going to be perpendicular to that line. Okay, so this line is basically going through the ground. All right, so let's see. All right, let's see which statement is not true. Let's see. So it says ET is perpendicular to plane BAD. So plane BAD, this plane right here, is still the same plane. Any 3 points, 3 distinct points on this plane also defines the plane. So BAD is on this plane right here. This plane, this green plane we have. So since these points are on this plane, these 3 points are on this plane, guess what? The plane defines a plane that is perpendicular to this line. So this is good. Checks out. All right, ET is perpendicular to FAB. FAB are 3 points that are on the same plane that we're talking about. Okay, remember, this line is perpendicular to any set of points that define this plane right here. So these 3 points define this plane that have 2 lines that are perpendicular to this line. Hence, it has to be perpendicular to this point, to this plane also. Okay, so that checks out. And then ET is perpendicular to CAD. These 3 points define the same plane. We're still talking about the same plane here. So this line has to be perpendicular to these 3 points, because they define the same plane that has 2 lines that are perpendicular to this line right here. So that's excellent also. ET is perpendicular to plane BAT. Plane BAT, we have a problem here. Plane BAT. Let's see. It looks like BAT is not on the same plane. Let me kind of draw this line right here. See BAT, let me indicate the points for you. Define a plane that contains the line that's perpendicular to this plane. So BAT right here. All right, let me show you how the plane looks like. The plane we were talking about, I'm gonna put in blue, is actually not. So this plane right here to there. Okay, so you see this plane right here is actually a big plane. That plane is actually parallel to the line that we actually drew earlier. It's parallel to the line. So plane BAT, this is, my sketch is not looking good. Plane BAT is parallel is not perpendicular. So plane BAT, this plane right here that I just sketched, is parallel to line ET. Okay, line ET is even in that plane right here. So plane BAT, which is this black plane right here, is not perpendicular to line ET. Okay, so this is plane BAT, and it is not perpendicular BAT, and it is not perpendicular to the line that we just looked at. Okay, the true statement would be that plane BAT is actually parallel to the line. Okay, because it has the same slope. So plane BAT is not perpendicular to line ET. All right, is not. So option number 4 is wrong. For any 3 points that define this green plane right here, is going to be perpendicular to this line. So that's the deal, bottom line. All right, so our answer is option number 4. So there you have it, because it's wrong. And that's it. So thanks so much for taking the time to watch this presentation. Feel free to subscribe to my channel by clicking up here so you can get updates to subsequent installments of this review series. And please post a comment to let me know what you think about this presentation. More clips come on Mathgotserved.com. Thanks again, and have a wonderful day.